Alrighty, so quadratic equations. So something like this, right? So you have something squared with some coefficient maybe, something by itself with a coefficient maybe, and then maybe plus something, and for now it'll equal 0, right? And we're going to solve these, and so what methods do you have? Just yell them out. Factoring, quadratic formula. Now, let's sound educated. The problem is the quadratic equation that we're solving, right? The tool that we use to solve it is the quadratic formula. There's a difference, okay? People call the quadratic formula the quadratic equation. It's not quite true, alrighty? There's another method. What is it?
Completing the square.
Completing the square. And another method. It's not a very good method, you're right. But you're looking for what? You graph it and you're looking for x-intercepts. Because I can change this from a quadratic equation to a quadratic function, right? Again, a slight difference. All these words, formula, equation, function, but they all mean something different, don't they? So here, x can be lots of things and y will be lots of things. But there's a specific situation when y is 0. We're graphing. Remember we talked about this last time. Think about the graph. When is y 0? Where are you when y is 0? On the x-axis. Bingo. X-intercepts. Right? Okay. What's up here? When do I have a real solution? Just yell out. Anything. Whole number. Whole is like too restrictive. It could be fractions. But how will we know if we have a real solution? It's a rational number where? You're right. In the discriminant. So probably this is the one we're going to look at. Just because you can't factor it doesn't mean it doesn't have real solutions, does it? You can always complete the square. You can always use the quadratic formula. So if the discriminant is what? Then I'll have a real solution. The number under the radical has to be what? Positive. And so that's the shorthand way to write positive. But I can also have the number under the radical be 0, can't I? And so we'll have a real solution. Okay? So when we have radicals, a positive number under the radical, you can write your answer in exact form, or you can use your handy dandy push button brain called the calculator to get an approximation. Okay, there is an interesting relationship between the product and sum of the roots. So let's take a very simple example. If we have x minus 3 and x plus 6 as factors, then who are the solutions? X equals 3 and negative 6. If I go back, was this the original problem? Yeah? Notice, if I multiply these two, I get the last term. If I add these two and take the opposite, I'll get the coefficient of the middle term, won't I? Add them and take the opposite. Okay? But that's only going to work if the coefficient of the square term is 1. Okay? So then, if I go back to the original, how do I make the coefficient of the square term 1? Divide by a. So that if I generalize this, if I say the roots are R1 and R2, if I multiply R1 times R2, what should I get? C over A. And if I add R1 and R2, I should get what? The opposite of the middle term. It's coefficient. With that in mind, then, they're going to give you, see, given, roots, and then they want you to find the question that those roots are from. So you're going to do what with R1 and R2? Multiply them, and you'll get C. Now notice that that's little c. Right? Actually, it doesn't matter. Actually, whoa. You're going to get maybe not C. I take that back. Little c, big C didn't matter here. What did they not do? Divide by A. But here's what you're going to do. You're going to say, you're going to take the R1 and R2, and you're going to multiply them, right? And get the last term, but you'll have a 1 here already. So you just put that number here. Then you add them and take the opposite and put that number in front of the x, and you'll have it. Now, here's what's going to happen, though. Maybe. See this right here? So let's say the solutions they give you are 2/5 and 3/5. What's the last term going to be? Six 25ths. And who is the middle coefficient going to be? 1. But it's really -1, right? It's the opposite of the sum. Got it? Equation, it's got to equal 0. Don't forget the equal 0. But they want the coefficients to be, so multiply through by 25, and your A value in front will naturally occur. You don't have to make it happen. It'll happen on its own. All right? So this dividing by A business is not going to really bother you. Not going to come into play. It'll come into play, though, when the directions say, make sure your coefficients are integers. All right, so first of all, let's set this equal to 0. So it's x squared plus root 2 minus 1 of x, and then minus, or times x, equals root 2. Okay? Now we said a moment ago that the two answers, R1, let's say, times R2, has to equal the last term. Well, probably what pops into mind is -1 and root 2, or 1 and negative root 2. What do you think? Easy 2 to kind of come up with so that I can multiply and make that last term. So then now, the idea is, which 2 do I add, not to get this, but to get its opposite? And I'm thinking this looks pretty good. So I think we're done. Now if you want to show more, you don't have to. You could say, well, let's see. Will this work? You see it? You see the negative root 2? Do you see the negative 1x and the positive root 2x? Otherwise, what you'd have to do is, if you're going to use the quadratic formula and create pain for yourself, a is going to be 1, b is going to be this whole thing. That's all of b, isn't it? And c is this. And you could plug it into the quadratic formula, but I'm already done. Right? So notice, if you have nice numbers, you can kind of get around brute force. So going back to something you brought up earlier, who is the discriminant? Just recite it to me. What's the thing under the radical? b squared minus 4ac. And we'll kind of sort of make this a piecewise function, but not really. But we could do this, right? If the discriminant, we'll call this like big D. If the discriminant is greater than 0, I have what? 2 real solutions. If the discriminant equals 0, I get 1. And if the discriminant is less than 0, and I'm talking about just real solutions, then I'm going to get none. You're right, for those that know more, you will get 2 imaginary solutions. You're right. But here, we're just talking about real. So first I think we need to organize this. So it's 2 pi y squared. This looks like a to me. Plus pi x y. That looks like b to me, because we're dealing with y, right? Y is a star variable. Minus 12 equals 0. And there's no way I can break up 12 like 3 times 4 or 2 times 6 and then talk about pi x at the same time. So we're not going to use that shortcut. And so we'll just crank out the quadratic formula. So who does the quadratic formula equal? What goes on the left? X, strike 1. Y. In this case, you're solving for y. Normally, you're right, it is x. But that's why I did it that way. I'm going to make sure you think about what goes, and not just have these knee-jerk reactions. Okay? So then we have what after the equal sign? Negative pi x plus or minus square root of pi squared x squared, or pi x quantity squared. What? Minus 4 times 2 pi times negative 12. That negative 12 pretty much guarantees that this is a real solution, that this is positive. You know what I'm saying? Because I think everything before it is positive. When you square stuff, it's always positive. Over what? 2a, and that's going to be what? 4 pi? Yeah, 2 times 2 pi, you're right. And then we just clean that up. And we get pi squared x squared plus, is that like 96 pi? Now, yes and no. Yes, you could factor out a pi, but it's not going to get you anywhere. If you were to factor out a pi squared, under the radical, then it could pop out. And then, obviously, I hope you know, this 4 and this 96 have nothing to do with each other, because one's in a radical and one's not. So don't start reducing like a mad person. Okay? So, to talk about discriminant, good. Got to multiply stuff out, correct?
Yeah.
So we have x squared, and we have, what is it? Minus qx minus px plus pq equals, oh, let's do this. Yeah, we might as well save a step, minus r squared equals 0. And so the thought was, two distinct real roots, that this must have something to do with discriminants. That was good too. I think you're on the right track. Okay? So then we write this in a way that maybe is a bit more compact. And we see this as being B, and we see this as being C. Alright, so with that hint, why don't you guys go ahead and write this out, or write out just the discriminant, and see what that leads to. So let's see, b squared minus 4ac. B is negative p plus q. And if I package that like this, minus 4 times a is easy, times c, and the big question is this greater than 0? So let's see, this might work, might not. One way to look at this is, okay, this is squared. That's guaranteed to be what? Positive. R squared is guaranteed to be positive. But did anybody come up with any ideas of what PQ had to be or didn't have to be? Okay, let me see if this gets us anywhere. If I actually square this, do you see p squared coming? Do you see 2pq coming? Do you see q squared coming? And then if I multiply this out, do you see negative 4pq plus 4r squared? Is that right? And then do you see p squared minus 2pq plus q squared plus 4r squared? And then do you see p minus q squared plus 4r squared? This guy's squared, this guy's squared, and this guy's positive. I'm thinking everybody's positive. What do you think? So here's the issue. You are Harvard-Westlake students. You are all bright. But the problem with your kind of brightness is maybe when you were younger, you saw the answer coming and you were able to work towards it. That's good. But what needs to start to develop is you can't see the answer coming. and you get to try stuff, and then maybe it will appear. And it's less comfortable because you're not sure what you're doing is right. But it's okay. Try it. That's what scratch paper is all about. Now I know, quizzes and tests, you hope this never happens, right? Because you don't have time to think like that. But in general, that's what's going on here. You gotta try stuff. Okay, before I start, there was one phrase I heard that reminded me of something. The phrase was, how did you know to do that? And probably the answer was, I didn't. I just tried something. Because again, you can't see it coming maybe. So you're not going to know before you start. You know what I'm saying? Anyways, so A and B are the solutions. They do work. And here is the equation. So what's A times B? Q. Write that down so you can see it. It becomes part of your visual knowledge. And then A plus B is going to equal what? Negative P. And then I heard some good ideas. I think many of you got this. You go, oh, let's just try factoring this. Just try it. What's common? A, B. And what's left? A plus B. You go, look at it. It's all here. AB is Q, and A plus B is minus P. And if I do this, I have everything in terms of P and Q. And I think when that appeared, then you were like, you get this rush, right? Like, yes! But before that, you go, well, I'm just going to try stuff. Okay? Over here, we're going to factor out of AB again. And what do we have left? A squared plus B squared. And you go, I don't see anything here. Do you? But there's this crazy thing that mathematicians do. They just add stuff. And they go, well, you know, that thing in the parentheses would look a lot nicer if I added a 2AB. And you're saying, you can just do that? Oh, no. You know how Mr. Mori grades tests, right? Mr. Mori giveth, and Mr. Mori taketh away, right? And so if he addeth 2AB, he's going to also subtracteth 2AB. And now look, everybody has somebody that you can refer to, because what does this become? A plus B squared. And now everything can be written, right? AB is what? Q. A plus B squared is P squared minus AB is